Alright, welcome to this lesson. We're going to be doing solving inequality word problems. Now you have these nice little boxes here that are going to help you with this problem, but I have to say, when these boxes go away and you have to solve it yourself, don't stop following these steps. This is the best way that you can use to solve any inequality word problem. So let's just jump into it. University Prep is having its annual spring dance and it will cost the school $400 to put on. It is going to be lit. The school says it has $75 it can use to pay for the dance, and it will need to charge $4 per ticket to cover the rest of the cost of the dance. Let T represent the number of tickets sold. What is the minimum number of tickets that must be sold to fund the dance? So first thing to do is let's underline the important information. All right, it's going to cost the school $400 to put on. The school will give us $75 to help pay for it. And tickets are $4 per ticket. All right, that is pretty important stuff. So what this is trying to do, we're trying to figure out how many tickets we're selling so we can pay for this dance. Well, let's get into it. First, we want to define our unknowns. This is just like we did before. What don't we know in this problem? I want you to take a second, pause the video, and write down what you think the variable should be for this problem. All right, what don't we know? Pause it, do it. I know you're not doing it. You're just waiting for me. You do it. Alright, now if you're unpaused, the variable should be x equals the number of tickets sold. That is our unknown, right? We don't know that, and if we do know it, that will tell us how much money we've earned, right? Because that's how many tickets we sold. Now we're going to write this equation in words, alright? The thing to do here is figure out first, well, how much, let's figure out how we're going to earn that $500 or $400. So let's see. We know we need $400, so that's going to be on one side of the equation. All right. And on the other side, it's going to be how much we earn. So we have $75, that's for sure. All right. Plus whatever we earn from selling tickets. Now, how do we figure out how much we earn from selling tickets? It's going to be, well, $4 for every ticket we sell. So it's going to be 4 times the number of tickets, right? Times the number of tickets. Wow, this is ugly. This is ugly. Now the big thing is here is figuring out which direction should this point in. On this side, we have the amount of money we're earning, right? That's $75 plus $4 for every ticket we sell. And on this side, we have $400. Well, we know that we want the amount we earn to be greater than or equal to $400. And that's the big challenge here, right? We want to earn more than, this side should be greater than the $400. So putting this sign in the right direction is the most important thing here. Well, let's keep setting this up. This is going to be $75 plus 4, and the number of tickets, right, is x. So it's going to be 4x. Has to be greater than or equal to 400. Well, now let's solve this question. We're trying to figure out how many tickets we have to sell to earn more than or equal to $400. Well, let's bring that all over here. Has to be greater than or equal to 400. You guys should be pros at solving this now. So we're going to subtract 75 from both sides. Okay. Let's put a line down the middle. That's my favorite way to do it. Variables on this side because it's the only side with variables. Numbers on this side. Cancels. And we get 4x to be greater than or equal to 325. Divide both sides by 4. And we get, x has to be greater than or equal to 81.25. Now the thing is here, this is where you really got to start thinking. The number of tickets sold has to be 81.25, right? But you can't sell 0.25 tickets. So if the question is asking how many tickets you have to sell, well, 81 wouldn't be enough. So the real answer is going to be 82, all right? Because you need full numbers of tickets. Don't forget that. You can't sell a quarter of a ticket. So sometimes you really got to just round up to 82. All right, let's try another problem. Having a fall carnival, admission into the carnival is $3 and each game inside the carnival is 25 cents. What is the maximum number of games that can be played if you only brought $10? Yep, should have brought more, but let's see how much we can play. First thing, define or varies. What don't we know? Pause the video, write down what you think we don't know here that we need to know. Okay, well that would be the amount, the number of games played. We don't know how many games we play. Okay. Now let's go and set up our equation in words. We're just going to write it out, right? So we know that we only have $10, right? And we're going to spend that at the carnival. To go to the carnival, it's the admission, so it's going to be the admission, which is $3 plus, whatever we spend on the game. So it's going to be 25 cents per game times the number of games we play. Does that make sense? So we have to spend $3 on the admission and then 25 cents for each game we play. Now, once again, we have to figure out what direction it's going to go in. So we know that this amount of money needs to be less than or equal to $10. Right? We can't spend more than the money we have, so we know that the amount of money we spend has to be less than $10. It's important that you figure out which direction it goes in and figure out why, be smart about it. Let's write this out. So we know that $3 plus 0.25, which is 25 cents, times, well, the number of games played, 25x. Right? We're just transferring that into an x now. Has to be less than or equal to 10. Let's solve this. $3 plus 25 cents has to be less than or equal to 10. You could drop the dollar signs, they're not important. Let's solve this. Line down the middle, subtract 3 from both sides, and we get 0.25x has to be less than or equal to 7. Divide both sides by 0.25, and we get x is less than or equal to, well, let's see, that should be 28. And that is our answer. Now we can't play 28 games, it's not decimal, so that number makes sense. So we could play anywhere less than 28 games. Looking good so far, guys. Now, at this point, if you feel like you got this, solve the next two problems by yourself, all right? And then just come back and see if you got them right. Or, if you don't feel like you got this, pay attention for the rest of the video, all right? The librarian at the Pike County Library could spend up to $3,900 to expand the children's section of the library. When she buys from a particular discount seller, paperback books cost $2 each, and hardback books cost $5 each. Write the inequality that describes the situation. Use X to represent the number of paperback books and Y to represent the number of hardback books. All right? Well, for this question, let's just get into it. What don't we know? Well, it actually told us what we don't know. Sometimes we're lucky enough to have that X is the number of paperbacks. And Y is the number of hardcover. So we're going to write this out in words, okay? We know that it's going to cost $3,900, okay? And we know that, well, if we want to find out how much this costs, it's going to be $2 for every paperback. So it's $2 times the paperbacks plus $5 times the hardbacks. Man, I should have put more space here. So $2 times every paperback plus $5 times every hardback will give us the total cost. Now we have to figure out which direction this goes in. Well, we know that we have to spend less than or equal to $3,900, right? We can't spend more than because... Sorry about that. So we know that it has to be less than or equal to $3,900. We have to spend less than, right? Because we could spend up to $3,900. We can't spend more money than we have, so this has to be less than $3,900. Well, we know paperback books are X, and we know hardcover books are Y, and that is our equation. Now, this question only asks us to write the inequality, so there's nothing to solve here. Sometimes you don't even need to do that part. So for our final problem, I'm not going to help you with this, but I will provide the answer. So at this point, I would like it if you just pause the video Really pause it and then come back and see if you got everything right here, okay? I'm going to write down the answer now, but pause the video. Pause it. Pause it. You should have figured out that you have three variables here. X equals the number of shoes, Y equals number of pants, and Z equals number of jackets. Doesn't matter what you used here. You could have used S for shoes, P for pants, and J for jackets, just as long as you had these three variables here, all right? And that's the amount of each one. For here, well, obviously I couldn't fit it in, but you should have said the number of the pounds of shoes plus the number of the pounds of jackets plus the number of pounds of pants. It must be less than 120. It's important that you had less than here. And then your final thing should have been 6 pounds times the number of shoes plus 2 pounds times the number of pants plus 8 pounds times the number of jackets should be less than or equal to 120. And you didn't have anything to solve here. You just had to write the inequality that represents this. All right. Well, that's it. So hopefully this helps, and good luck on this lesson.